Extended read-write times. Imagine you ask a librarian to find a specific book for you. Normally, they walk right to the correct shelf, grab the book, and hand it to you in seconds. But what if the library was completely disorganized, with pages of the book scattered across 10 different rooms? Or what if the pages were torn, and the librarian had to squint and reread the same sentence 5 times to figure out what it said? It would take them an incredibly long time to bring you the information. This is exactly what is happening inside a computer when you experience extended read and write times. When you are studying for your CompTIA A+ Core 1 exam, you need to recognize this symptom. It looks like a computer that freezes for several seconds every time you try to save a document or open a new program. The mouse might still move, but the application simply hangs while it waits for the storage drive to do its job. To get your perfect 900 score, you must understand the deep mechanical and electrical reasons why storage drives slow down and exactly how to troubleshoot them. Let us take a deep technical dive into why a traditional mechanical hard disk drive suffers from extended read and write times. The most common logical cause is heavy file fragmentation. When you save a large video file or install a new program, the operating system tries to write all the data into one continuous block on the spinning magnetic platter. However, as the drive fills up over months and years of use, the empty space becomes scattered in tiny chunks. The operating system is forced to chop the file into hundreds of microscopic pieces and scatter them all over the disk. When you ask the computer to open that file, the physical metal read and write head has to frantically dart back and forth across the spinning platter to collect all the scattered pieces. This mechanical movement takes a massive amount of physical time, causing the drive's performance to crawl to a halt. To troubleshoot this logical issue on the exam, the correct professional step is to run a disk defragmentation utility, which physically reorganizes the data blocks back into continuous sequential lines, allowing the read head to sweep smoothly and quickly. However, if the drive is perfectly defragmented but is still incredibly slow, you are likely looking at a physical hardware degradation. As a mechanical hard drive ages, the magnetic coating on the platters begins to lose its strength, or the read head gets physically weak. When the drive tries to read a sector, the signal is too fuzzy, so the drive's internal controller throws a read error and forces the read head to wait for the platter to spin all the way around again to try a second time. If the sector is slightly damaged, the drive might have to retry reading that exact same spot 50 times before it finally gets the correct data. This constant retraying is completely invisible to the user, but it causes massive extended read times because the entire operating system has to wait for the drive to succeed. You would diagnose this by looking at the self-monitoring analysis and reporting technology attributes, specifically looking for a high raw read error rate or pending sector count. You must also understand how this symptom presents on modern solid-state drives. Because solid-state drives have no moving parts, they do not suffer from mechanical fragmentation, and you should absolutely never run a defragmentation utility on them, as it will only waste their limited lifespan by burning through write cycles unnecessarily. Instead, extended write times on a solid-state drive are almost always caused by the drive being too full. Solid-state drives store data in microscopic NAND flash memory cells grouped into pages and blocks. Because of the way flash memory works, you can write data to an empty page very quickly. But if you want to overwrite an old file, the drive controller cannot just overwrite a single page. It has to read an entire massive block of data into its cache, erase the entire physical block, and then rewrite the mixed old and new data back into the flash memory. This is called the read-modify-write cycle. When a solid-state drive reaches 90% capacity or higher, it completely runs out of empty blocks. Every single time you try to save a tiny text file, the drive controller is forced to perform that heavy, time-consuming read-modify-write cycle, which completely destroys the write speed of the drive, making the entire computer feel sluggish. To troubleshoot this specific issue on your exam, you must check the total capacity of the drive and instruct the user to delete old files or migrate to a larger drive, so the controller has at least 10 to 15% free space to maneuver. You should also verify that the operating system is sending the trim command to the drive. The trim command tells the solid-state drive controller exactly which files the user has deleted in the operating system, so the drive can proactively clean out those unused blocks in the background during its idle time. By understanding the massive difference between mechanical fragmentation and flash memory block erasing, you will easily conquer any performance troubleshooting scenarios on your certification test.